Good morning, students of Standard 9. Welcome back to the chemistry class. Dear students, we are talking about Chapter 5, Chemical Bond. Last class, we had learned about chemical bond. Today, in this class, we will discuss about ionic bond formation. Last class, we had learned the attraction force by which the atoms of molecule are attached with one another is called chemical bond. And there are different types of bonds. These are ionic bond, covalent bond, coordinate bond, metallic bond, etc. Today, in this class, we will discuss about ionic bond. What is ionic bond? Ionic bond is a type of bond that exists between a metal and a non-metal. Here, metal releases electron and after releasing electron, metal forms positively charged ion or cation. And non-metal accepts the electrons released by metal and forms negatively charged ion or anion. These two oppositely charged cation and anion are joined together by ionic bond. So what is ionic bond? The attractive force by which cations and anions formed by exchanging of electrons are held within the molecule of a compound is called the ionic bond, or it can be also called electrovalent bond. For example, sodium chloride, compound of sodium metal and chlorine nonmetal, sodium oxide, compound of sodium and oxygen, calcium fluoride, magnesium oxide, aluminium chloride, magnesium fluoride, etc. All these compounds are made up of one metal and one non-metal. So these compounds are ionic compounds because in these compounds ionic bond is present. Now look, these common metals and non-metals, they form ionic compound. Sodium, magnesium, aluminium, potassium, calcium, these are common metal. And non-metals, oxygen, fluorine, chlorine, these are common non-metals. So these every metal can form ionic bond with these non-metals. Here look, sodium. Here metal sodium can make ionic bond with oxygen, fluorine and chlorine also. Here when sodium and oxygen make a bond, then this compound is called sodium oxide, where two sodium atoms and one oxygen atom is present. Na2O, two sodium atoms and one oxygen atom. Sodium and fluorine make sodium fluoride, NaF, where one sodium atom and one fluorine atom are present. Sodium can make compound with chlorine also, formula sodium chloride, NaCl. Here also one sodium atom and one chlorine atom make this bond. Here for every case, metal sodium, it releases electron and non-metal, these accept electron. For sodium oxide, two sodium atoms release two electrons and one oxygen atom accepts those two electrons. For sodium fluoride and sodium chloride, sodium releases one electron and fluorine or chlorine accepts this electron released by sodium. Now, bond of magnesium with other non-metal, magnesium oxide, magnesium fluoride, magnesium chloride. When magnesium and oxygen make bond, this is called magnesium oxide, where magnesium releases two electrons and one oxygen atom accepts those two electrons released by magnesium. For magnesium fluoride and magnesium chloride, one magnesium atom releases 2 electrons, but fluorine or chlorine, they need only 1 electron. So 2 fluorine atom or 2 chlorine atoms come to accept those 2 electrons released by magnesium. So the formula of magnesium fluoride or magnesium chloride are MgF2 and MgCl2. Again, when aluminium makes bond with oxygen, fluorine or chlorine, then aluminium and oxygen, the formula of aluminium oxide is Al2O3. That means 2 aluminium atoms make bond with 3 oxygen atoms, because 1 aluminium atom releases 3 electrons, but oxygen atom needs only 2 electrons. So 2 aluminium atoms, they release total 6 electrons, and these 6 electrons are accepted by 3 oxygen atoms and they make Al2O3. Aluminium fluoride, here 1 aluminium atom releases 3 electrons and 3 fluorine atoms come to accept those 3 electrons released by 1 aluminium atom. So the formula of aluminium fluoride is AlF3. For aluminium chloride also same. Aluminium releases 3 electrons and 3 chlorine atoms accept those 3 electrons of aluminium, and the formula of aluminium chloride is AlCl3. In this way, potassium, calcium and other metal, zinc, iron, other all metals, they make ionic bond with other non-metals. Not only this, one cation and one anion, that means any negatively charged radical anion or radical, they can make bond with any metal or any positively charged radical, and this bond is also called ionic bond. Now we will read the bond formation of sodium chloride, where the bond is made by sodium and chlorine. Sodium as a metal, it releases 1 electron from its outermost shell, because it has only 1 electron on its third shell. And chlorine, the electronic configuration of chlorine is 287, so it needs 1 electron to complete its octet. So sodium releases 1 electron and chlorine accepts this 1 electron. After releasing 1 electron, sodium becomes positively charged ion or cation, and it will gain the electronic configuration of its nearest inert gas, neon. And in this way, sodium becomes stable by forming sodium ion, Na+ cation. And it, after releasing 1 electron, now its number of proton is more than electron, because 1 electron is released from sodium, so it becomes Na+ sodium ion. In the same way, chlorine also makes anion. Look, sodium, there are 11 proton and 11 electron, so it is neutral, but sodium ion, here 1 electron is released from sodium, so it has now 10 electron and 11 proton, so it becomes positively charged ion or cation. In the same way, chlorine, it has 7 electrons on its outermost shell, so it needs 1 electron and it accepts the released electron of sodium. And after accepting 1 electron on its last shell, chlorine becomes a negatively charged ion or anion, and it will gain the electronic configuration of its nearest inert gas, argon. In this way, chlorine also becomes stable, but it forms Cl- ion, chloride ion, because at first in neutral atom it has 17 electron and 17 proton, so it was neutral. But after accepting 1 electron, now it has 18 electrons and 17 protons, so it becomes negatively charged ion or anion. Look here. This electron, it goes to chlorine atom and sodium becomes Na plus ion and chlorine becomes Cl minus ion. Now, one positive ion sodium plus and one negative ion Cl minus, there is an attraction force between these two oppositely charged ions. This attraction force is called ionic bond. Here, sodium and chlorine, they make positive and negative ion and they are bonded together to make NaCl or sodium chloride. So sodium chloride is bonded by ionic bond and sodium chloride is an ionic compound. Look the diagram. When you will write the bond formation, then this diagram and the equation electron exchange, this is must for you. You have to write this. Here look, the electronic configuration of sodium and chlorine, but after releasing electron, this is now sodium ion and this is chloride ion. So they are bonded together and they make sodium chloride ionic compound. In this way, lithium fluoride, where lithium releases one electron and fluorine accepts this released electron of lithium and they make lithium fluoride ionic compound. Lithium chloride, this is also like this way. Sodium fluoride, here also sodium releases one electron and fluorine accepts this electron of sodium. Potassium fluoride, potassium chloride, these all are formed by the same way of sodium chloride. Now we will read the bond formation of magnesium fluoride. Same process, but here magnesium releases two electrons but fluorine needs one electron. So two fluorine atoms will come to accept those released electron of magnesium. Here the electronic configuration of magnesium is 282. So magnesium releases two electrons and the electronic configuration of fluorine is 27. So fluorine needs one electron. So when magnesium and fluorine come close to one another, magnesium releases two electrons and after releasing two electrons, magnesium get the electronic configuration of its nearest inert gas neon. But after releasing electron, magnesium becomes a dipositively charged ion or cation. Here look, magnesium releases two electrons. So it becomes Mg2 plus because now it has two electrons less than its proton. Look here. Here magnesium has 12 electron and 12 proton. So it was neutral. But when magnesium releases two electrons, then after releasing two electrons, this magnesium ion, it has 12 proton but 10 electron. So it is now dipositively charged ion. Now fluorine, it needs one electron but magnesium releases two electrons. So to accept these two electrons, two fluorine atoms come and both they accept two electrons and both fluorine atoms get the electronic configuration of their nearest inert gas neon and becomes a negatively charged ion or anion like this way. After accepting one electron, fluorine becomes fluoride ion F minus. Here there are 9 electron and 9 proton, but there are 9 proton and 10 electrons. So it becomes negatively charged ion or anion. Look, these two electrons both are accepted by two fluorine atoms. So one magnesium cation, dipositively charged cation, and two fluoride ion, anion, are formed here. Now an attraction force works between these two oppositely charged ions and this attraction force is called ionic bond. Here One magnesium atom releases 2 electrons, so it forms Mg2 plus dipositively charged ion, and 2 fluorine atoms, they accept the 2 electrons released by magnesium and both they make fluoride ion and it forms MgF2, magnesium fluoride, an ionic compound. In this way, magnesium fluoride is bonded and magnesium fluoride ionic compound is formed. Now, similarly, like magnesium fluoride, magnesium chloride, calcium chloride, these are formed. Here, calcium also releases 2 electrons and fluorine and chlorine, they need 1 electron. So, 2 fluorine atoms or 2 chlorine atoms will come to bond with 1 magnesium or 1 calcium atom. Now bond formation of calcium sulfide, look here. Here also calcium has 2 electrons on its outer shell and sulfur has 6 electrons on its outer shell. So calcium releases 2 electrons and sulfur accepts those 2 electrons released by 1 calcium atom. So 1 calcium atom make dipositively charged ion Ca2 plus and 1 sulfur atom makes dinegatively charged ion S2 minus and they make calcium sulfide. Look, by releasing 2 electrons, calcium makes Ca2 plus and by accepting 2 electrons, sulfur make S2 minus. And this positively charged ion and this negatively charged ion, there is an attraction force and they are bonded together and they make calcium sulfide, CaS, like this way. In the same way, like calcium sulfide, magnesium oxide, calcium oxide, magnesium sulfide, these compounds are formed because all these compounds, magnesium and calcium are cation and oxygen and sulfur are anion. Magnesium and calcium are metal and they form cation and oxygen and sulfur are non-metal and they form anion. Where magnesium and calcium release 2 electrons and oxygen or sulfur, they accept 2 electrons and they are bonded by ionic bond. Now look, bond formation of lithium oxide, Li2O. Look, lithium, its electronic configuration is 2,1. So, lithium releases 1 electron from its outer shell and oxygen, it needs 2 electrons. So, where another electron it will get from where? 2 lithium atoms will release 2 electrons and these 2 electrons are accepted by 1 oxygen atom. So 2 lithium atom after releasing electrons they will make lithium cation Li plus and after accepting these 2 electrons 1 oxygen atom it makes O2 minus ion and they are bonded together and they form Li2O. 2 lithium atom both release 2 electrons, each releases 1 electron. So 2 lithium atoms release 2 electrons and they form 2 Li plus and 1 oxygen atom, it accepts these 2 electrons released by 2 lithium atom and form O2 minus. And an attraction force works between this cation and anion and they make Li2O, lithium oxide. In the same way, sodium oxide, potassium oxide, sodium sulfide, potassium sulfide are formed. Where sodium, potassium, they are also metal, they release 1 electron and oxygen or sulfur, they need 2 electrons. So 2 sodium atoms or 2 potassium atoms will come and make bond with 1 oxygen or 1 sulfur atom and they are bonded like this way and they make Na2O, K2O, Na2S, K2S, etc. Like this way. Lithium releases this electron and 2 lithium atoms they release 2 electrons, and these 2 electrons are accepted by one oxygen atom. Now, bond formation of aluminium oxide Al2O3, where aluminium has 3 electrons on its outer shell. So, aluminium releases these 3 electrons and oxygen needs 2 electrons. So, another electron will go here. So, another aluminium atom will come, and both aluminium atoms, they release total 6 electrons, and 6 electrons are distributed among 3 oxygen atoms, and 2 aluminium atoms and 3 oxygen atoms are bonded together to make Al2O3, aluminium oxide, like this way. 2 aluminium atoms, they, after releasing 3 electrons, they make +3, and 2 oxygen atoms, after accepting 2 electrons, they make O2 minus, like this way. 2 aluminium atom releasing 6 electrons, and they make 2 aluminium ion, 2 Al3 plus, and 3 oxygen atoms. Total they accept 6 electrons, and they make 3 O2 minus, and they are bonded together like this way, and they make Al2O3. So dear students, today up to this we have completed ionic bond today. Thank you everyone. See you in next class.